Okay, AP Physics, assignment number 6, reviewing for this AP test coming up. This question is intended to be a longer FRQ, about 25 minutes long, and it looks like the goal is to describe an experiment that would determine the coefficient of static friction between a wood board and a wood block. They want a diagram of your setup. They want you to identify all measurements. They want you to come up with a procedure that can be repeated, and then they want you to derive an equation for the coefficient of static friction in terms of the quantities that were measured. Okay, so that was A and B. I put A and B together here. So here's my thinking on A and B. I started by just thinking about the forces on a wood block that would be on an incline. So I have the weight, mg, force due to gravity. I got normal, which would be the cosine theta mg. Remember that normal would be the equal and opposite force to the perpendicular force, which is it's the side that's adjacent to theta here. And remember that theta right here, this angle is the same as theta with the angle of the incline with the parallel. So anyway, I got cosine theta mg being normal because it's equal to the perpendicular component of the weight, and then I've got force of friction here, which I've identified as sine theta mg because that is equal and opposite to this component here, which is the parallel component, which is sine theta mg. So then if you think about our expression for force of friction being mu times normal, and you rearrange that for mu, then mu would be the force of friction divided by the normal, or sine theta mg over cosine theta mg, where mg cancels out, and sine theta over cosine theta is just tan theta. So I thought about that and realized that if that's true, then mu is just the tangent of theta, where theta is the angle that would cause the block to just barely start moving. So we want to raise the angle of the incline with the block on it until we reach an angle where it just starts to slide. So that would be the angle, that would be the maximum angle where that block could sit there and still be at rest. Anything beyond that would cause the block to slide. And since they're looking for static friction, we're looking for the block to still be at rest. So that would be how I would find mu. So the only thing I had to do is measure the angle. So determine the angle that causes the block to just barely move. And I said repeat this, quite a few times and try to get an average. And that's how I answered I, and B. So here's my experiment. I needed a protractor, I needed the board and the block. I didn't even have to measure the mass of the block. So that's my thinking on A and B. C, they're referencing data by different lab groups, and from the data, the class average for the coefficient of kinetic friction is 0.49, and for static friction it's also 0.49. And they're asking, based on these data, what conclusions should the students make about the hypothesis that static and kinetic friction are equal? Well, based on the averages, it looks equal, but if you look at group number 5 here, group number 5's data is significantly different from the other groups. So I think group 5 made an error. So what I said is, no, they're not equal. Group 5 should be removed. It's an outlier. And then if you remove their data, the averages are no longer equal, and the static coefficient would be a larger number than the kinetic coefficient of friction. And then for D, it says a metal disc is glued to the top of the wood block. The mass of the block disc system is twice that of the block. Does the coefficient of static friction between the block change, increase, decrease, or remain the same? I said remains the same. And the reason why I said remains the same is because what I said prior, the coefficient of friction is the ratio of the force of friction to the normal. So if you're going to change the mass, you're changing both of these. So in the end, the coefficient of friction static friction is just determined by the angle, tan of theta. So mass is not a factor. And that's my thinking on D. Hope you guys are doing well. Use this to correct your own thinking, and have a good day.